Alright, sorry for the abrupt ending just now. So let's continue. So we were saying that for a three-phase system, instead of using 3 wattmeters, I can actually use 2 wattmeters to measure the total power. So in this circuit here, who is my reference? B is my reference. Alright, so the wattmeter A, the voltage is A with respect to B. And for wattmeter C, voltage is C with respect to B. Why B? Because I make him the reference. So mathematically can be proven that the total power in this three-phase system is the sum of the reading that I get from wattmeter A and wattmeter C. Okay, so the challenge now for us is how do I find WA? Okay, now you still remember what power, true power, is going to be I cosine theta. Agree? Okay, now then you ask yourself, in this wattmeters here, who is my V? V is the AB. So it's VAB. VAB. And what is my I? My I is IA. The current through I. So it's IA. Cosine theta. Okay? Right, how about WC? WC is VI cosine theta again. So it will be VCB. Because with respect to my reference. So it's VCB. So it's VCB. And the current is IC cosine theta. Right? Now then the mathematics goes is with how do you get all these readings? How do you get this VI cosine theta value? Now then you have to actually go back to the Phasor diagram that we had before. Can you remember this Phasor diagram? Alright, now how do we calculate the VAB? Remember? So here is 30 degree and VAB is 30 degree. If VAN is a reference. If I change my reference, my VAB will have a different angle. Right? So let's take it that I'm using this Phasor diagram, VAN is a reference in my system. So I come back here. So I will say that my VAB is equal to 230 volt, 400 volt, 30 degrees. Alright? And if I were to say that IA is equal to 1.5 minus 30 degree ampere. And can you tell me what's theta? Theta is the angle between the voltage and the current, right? So 30 and minus 30, in between is 60. Or you say theta V minus theta I is 30 minus 30, so it's therefore 60 degrees. So this is 60 degrees. Get it? So in other words, I'm trying to tell you that to find VAB, you have to base on the Phasor diagram. And to find the current, you must do your mathematics like what we did in topic 1. Okay, now WC, wattmeter C, VCB. So again, if I will refer back to my Phasor diagram here, VCB, so this is VBC, that's minus 90 degree. So VCB is you have to toggle the Phasor to the other side, right? So VCB is 90 degree. So this is 90 degree. Okay, 490 degree. Right? How about my IC? I fake a value. Let's say IC is equal to 3.1, 40 degree. Okay? Now then what is theta? Theta is the angle between the V and the I. My V is 90 degree, my I is 40 degree. So the angle between them is 50 degree. Or you say theta V minus theta I. 90 minus 40, so here's 50 degree. Okay, so that is called 2 wattmeters measurement. So in order to do your mathematics of this, you actually have to go back to your topic 1. Look at the Phasor diagram again. See whether the question is talking about ABC sequence or ACB sequence. And you, based on the angle, do the mathematics accordingly. Right? Now, since I have a 3-phase here, I can make B the reference. Do you think I can make A as a reference? Can I make C as a reference? The answer is yes. Okay, let's try to go through it. Alright, so I have here 3-phase system A, B, C. So if I were to make B as a reference, That is how my diagram looks like. So this is WA and this is WC. And you have no problem telling me what is WA and what is WC, right? You say WA is equal to VAB IA cosine theta. And WC is equal to VCB IC cosine theta. Okay? Now what if my three-phase system now, I'm making this A, B, and C. I'm making A as a reference now. Okay, here is B is a reference. So now I want A as a reference. Right? If A is a reference, means my wattmeter now is at B and at C. Right? The voltage coil go to the reference point. The voltage coil go to the reference point. So this is WB and this is WC. Right? What is WB? VI cosine theta. Right? So what is it? VB A. A is a reference. So VBA IB cosine theta. How about WC? VCB. Oh, sorry, VCA. A is my reference, right? So VCA IC cosine theta. Get the hang of it? Right, the third one. Right, I started with B as a reference. We know how to do it already. A as a reference, we also know how to do it. Now C, I'm making C as a reference now. So the current coil, measure IA. Current coil, measure IB. The voltage coil now go to the reference. The voltage coil now go to the reference. So this is WA and this is WB. Right? So let's try WA. VI cosine theta. Which V? VAC. Which I? IA. Right? How about WC? WC will be VI cosine theta again. Which V? VC. Sorry, I'm wrong. It should be WP. Okay, make mistake. So WB. WB, the voltage is VBC. Right, C is the reference, and IB. Okay, so and that's called the 2 wattmeters method. So if you know the reading of the 2 wattmeters, the total power will be, you just add up the 2 reading. Right, and that will give you the true power, total power. Same thing, and the same thing here. Okay, so that's called 2 wattmeters method. Another formula in 2 wattmeter method is that if you know the reading of the WA and WB and WC, there is actually a formula for you to find the power factor. And the formula is called tangent theta. Right? Tangent theta is equal to square root 3, the 2 minus, and the 2 plus. And anyway, this formula is given to you. But I thought maybe I just teach you one way of how to remember this formula if you are not given. Now, if this is an ABC sequence, that's A minus B. Okay? Or it can be square root 3, B minus C. Or C minus A. So if you know of any 2 wattmeters reading, you can find the tangent theta. And from tangent theta, you can find tangent inverse. To find out the theta, you cosine it, you can find the power factor. Right? So this is one set of formula. And the other set, if it's ACB sequence, then the formula turn to tangent theta square root 3. So here's A minus C. Next one will be C minus B. The next one will be B minus A. Right? So it will be WA minus WC or WC minus WB, or WB minus WA. Now, which set of formula do you use? Depends on the question. If it's ABC sequence, you use this set. If it's ACB sequence, you use this set. Alright, this tangent theta formula is to enable you to find the power factor. Okay, and that is the end of AC power. No, actually there's one more thing. About AC power. Alright, I call it point number 6. Is this shortcut formula. Now remember, we say the total apparent power for a 3-phase. You can actually measure each one of them and sum it out, right? But if it is a balanced load, only apply for balanced load. There is a shortcut of square root 3 VL IL. Okay, square root 3 of VL IL. Now, and therefore the true power, remember, is equal to S cosine theta, right? So it's therefore square root 3 of VL IL cosine theta. Now, in 3-phase theory, sometimes you are a little bit confused with square root 3. Okay? Now, actually, it can be proven. Why is it that the total apparent power for a balanced load is equal to square root 3 VL IL? Okay, let's try to verify it, and you'll find it quite interesting. Now, if it is a star circuit, alright, if it is a star circuit, this is the line voltage and this is the phase voltage, right? And this is the line current and this is the phase current. Okay, now if I were to say that, okay, this is the 3 times of the individual, because if I know the individual power multiplied by 3, I should get the total, right? So let's do the 3 times of the individual. So I'll say individual phase voltage multiply individual phase current. Okay, now for this star circuit, the phase voltage is the line voltage divided by square root 3. Can you remember? They are not the same. Line voltage and phase voltage are not the same. Okay, phase voltage is line voltage divided by square root 3. Whereas line current and phase current is the same. So 3 divided by square root 3, you become square root 3. That's why the total apparent power can be square root 3 line voltage multiplied line current. Yeah? Do you know that 3 divided by square root 3 is equal to square root 3 times square root 3 divided by square root 3? So that becomes square root 3. Right? Okay, so that is a star system. Let us prove it on the star delta system. Now, if it is a delta system, okay, so this is the line voltage, and this is the phase voltage, and this is the line current, and this is the phase current. Right? Now, you must agree with me that the line voltage and the phase voltage is the same, whereas line current and phase current are not the same now. Right? So let's do our mathematics. Same is 3 times phase voltage multiply line current. This gives you the phase power, right? Since it's 3 phase, you multiply by 3, that should be the total. Now, phase voltage is the same as line voltage, whereas phase current is not the same as line current. Phase current is smaller than the line current by square root 3. Okay? So again, you have 3 divided by square root 3, so that becomes square root 3 VL IL. Right? So that proved to us that this shortcut formula can be used for balanced load. And of course, true power then is equal to S cosine theta, right? So if I want total true power, then it's total apparent power. So it's equal to square root 3 VL IL cosine theta. Okay? So that is the AC power. Alright, a quick summary of all the points that I talked about in AC power. Point number 1. How many types of AC power are there? 3. They are P, Q, and S. True power, reactive power, apparent power. Yeah? And the units for true power is Watt, reactive power is VAR, apparent power is VA. They form a right angle triangle. Pythagoras theorem can be used, trigonometry can be used. Right? 2. Power, you can use various formula to find power. You can use I square R formula if it's individual phase. You can use V square over R. You can use VI cosine theta. Right? If it's one phase. Yeah, individual phase, individual circuit. You can do that. Yeah, all the units must be in RMS. Okay. Then we talk about how do you sum up the different power. So if I have a 3-power triangle, P1, P2, P3, Q1, Q2, Q3, the total power you add it up because they are all horizontal. Whereas the total reactive power, you have to say Q1 minus Q2 plus Q3 in my example here, because this power triangle point down, the other two point up. Right? And then my total complex power is equal to PT plus JQT. Right? If my answer is negative, of course this will become negative. Okay? Then point number 4, we talk about the power factor correction. Alright, remember the old power triangle. When after power factor correction, the angle becomes smaller. And how did it happen? Because we introduced a capacitor in parallel to the circuit. Right? And then we went on to talk about the 2 wattmeters method. Right? Where you use one of them as a reference. So you have A, B, and C. Right? If I use this as my reference, then my wattmeter is here, the wattmeter is here. So what is in my WA? And what's in my WC? Right? Can you do your mathematics correctly to say this is VAB, IA cosine theta? And can you confidently say WC is going to be CB, IC cosine theta? Because I'm using B as a reference. So my voltage is C with respect to B, A with respect to B. And 2 wattmeters method, I can make B as a reference, I can also make A as a reference, or I can make C as a reference. Right? Then lastly, we talk about this shortcut formula. The total apparent power is equal to square root 3 VLIL. This one is only applied for balanced load. Right? And the true power is equal to square root 3 VLIL cosine theta. This shortcut formula is only for balanced load. Okay? Alright, cut.